How is sound produced? Sound is produced when something vibrates. The vibrating body causes the medium, such as water, air, etc., around it to vibrate. Vibrations in air are called traveling longitudinal waves, which we can hear. Sound waves consist of areas of high and low pressures called compressions and refractions. Interference. When two waves meet, there can be two kinds of interference patterns, constructive and destructive. Constructive interference is when two waveforms are added together. The peaks add with the peaks and the troughs add with the troughs, creating a louder sound. Destructive interference occurs when two waves are out of the phase, the peaks on one line up with the troughs on the other one. In this, the peaks cancel out the troughs, creating a diminished waveform. For example, if two waveforms meet, they are exactly the same that are added, the amplitude doubles, but when two opposite waveforms added, they cancel out, leaving silence. If a sound becomes louder, which wave characteristic is likely increasing? When sound becomes louder, the amplitude, intensity of the sound wave increases. Sound can travel through. Sound propagates by causing the particles in the medium to vibrate. A vibrating source transfers the vibrations to the surrounding medium, which can be solid, liquid, or gas. The resulting vibrations create varying pressure regions by compressing and decompressing the particles in the medium, and through this process of compression and decompression, sound waves propagate through the medium. During the propagation of sound, the particles of the medium receive these vibrations and transfer them to the surrounding particles, allowing sound to travel. In a vacuum, there are no particles that can transfer and carry vibrations, so sound cannot travel. The most well-known example of a near vacuum is outer space. Technically, space is not entirely empty and there are gas particles in space, but gases are much less dense than Earth's atmosphere in space, meaning that there are fewer particles per unit of volume in space. So although sound is propagated through space, how do we hear sound? When we detect sounds or noise, our body is changing the energy in sound waves into nerve impulses which the brain interprets. When we hear a sound, this is what actually takes place. Step 1. Sound waves enter the ear canal and cause the eardrum to vibrate. Step 2. Vibrations pass through the three connected bones in the middle ear. Step 3. This vibration sets fluids moving in the inner ear. Step 4. Moving fluid bends thousands of delicate hair-like cells which convert the vibrations into nerve impulses. Step 5. Nerve impulses are carried to the brain by the auditory nerve. Step 6. In the brain, these impulses are converted into what we hear as sound. Unlike light, sound can't travel through a vacuum. This is because light is an electromagnetic wave, whereas sound isn't. Electromagnetic waves can go through vacuums without having to bounce off something, whereas sound has to have a medium to bounce off, such as air or water. Which type of waves are the longest? When you listen to the radio, watch TV, or cook dinner in a microwave oven, you are using electromagnetic waves. Radio waves, television waves, and microwaves are all types of electromagnetic waves. They differ from each other in wavelength. Wavelength is the distance between one crest to the next. Waves in the electromagnetic spectrum vary in size from very long radio waves the size of buildings to very short gamma rays smaller than the size of the nucleus in an atom. Did you know that electromagnetic waves can not only be described by their wavelength, but also by their energy and frequency? All three of these things are related to each other mathematically. This means that it is correct to talk about the energy of an X-ray or the wavelength of a microwave or the frequency of a radio wave. The electromagnetic spectrum includes from longest wavelength to shortest. Radio waves are the longest, microwaves, infrared, optical, ultraviolet, X-rays, and gamma rays, which are the shortest. Does sound travel faster through air or water? Sound waves need to travel through a medium such as a solid, liquid, or gas. The sound waves move through each of these mediums by vibrating the molecules in the matter. The molecules in solids are packed very tightly, liquids not packed as tightly as solids, and gases are loosely packed. The spacing of the molecules enables sound to travel much faster through a solid than a gas. Sound travels about 4 times faster and farther in water than it does in air. This is why whales can communicate over huge distances in the ocean. Sound waves travel about 13 times faster in wood than in air. They also travel faster on hot days as the molecules bump into each other more often than when it is cold. Therefore, water is a better way of transport for sound than air. What is an echo? An echo is a repetition of sound produced by the reflection of sound waves from a wall, mountain, or other obstructing surface. What is the unit of measure for the loudness of sound? Volume relates to the maximum pressure produced as particles are squeezed together as they are made to vibrate. This is also related to the maximum distance particles are moved from their normal position. When you show sound waves on a graph, the amplitude is the height of the waves from their middle position and reflects how loud the waves are. Loudness of sound is measured in decibels. This is actually a measure of intensity, which relates to how much energy the pressure wave has. Decibels are a relative measurement. They relate the intensity of a pressure wave to a normal or standard pressure. For the human ear in air, the quietest noises we hear are around 10 decibels, whereas the sounds of 130 decibels are quite painful. What is the unit of measure for the frequency of sound? Pitch relates to the frequency or how many times a second the particles vibrate. The distance between one wave and the next gives the wavelength. For sounds all travelling at the same speed, high frequency sounds have very close together. Low frequency sounds have a greater distance between each wave. An extreme example is the low pitch calls made by humpback whales, which can have up to 100 meters between the pressure peaks of their sound waves. Frequency is measured in hertz for sound. This means the number of pressure waves for the sound that would move past a fixed point. It is also the same as the number of vibrations per second the particles are making as they transmit the sound. A sound of 10 Hz means that 10 waves would pass a fixed point in 1 second. Humans can normally hear sounds between 20 Hz and 20,000 Hz, also known as 20 kHz.